Hey everyone, Mr. Fritz here. In these two problems, we are converting between different vector forms. In this first problem, we want to find the component form given the following vector. Vector u has a magnitude of 13 and a bearing of 251. So let's start off by kind of visualizing what that looks like. So here's my compass. 251 is going to be over 180, but below 270. So let's draw that vector in. That has a magnitude of 13. This angle right here is 251. And if I want to find the components, I'm really interested in the x step and the y step. My horizontal vector plus my vertical vector is equal to my resultant vector u. This is u. And we know the magnitude of u is 13. Actually, let's label this 13 for the ease of this diagram. What I'm interested in is finding this angle right here. Let's put that back in red. I want this theta right here. And hopefully it makes sense that theta is going to be the difference between 270, if I were to keep going all the way around, and this 251. So if I subtract those two, I get an angle of 19 degrees. So 19 is actually what's in between, this acute angle between my x step and my resultant right here. That's 19 degrees. So I have an angle and I have a right triangle. This is a right triangle. So I'm just going to use some right triangle trig. The sine of 19 degrees is going to equal the opposite over the hypotenuse. So this is going to be my y over the 13. I can rewrite this as y is going to equal 13 times the sine of 19 degrees. And that comes out that comes out to be 4.2. Y equals 4.2. I can do the same thing with the x component. X is going to equal 13 times the cosine of 19 degrees, since this is going to be the adjacent over hypotenuse. That's the x. And that x comes out to be 12.3. So my component form is going to look like this. U vector u is going to equal, my x is 12.3, and my y is 4.2. So one thing that's really important to point out here is I'm not quite finished. So these are like the sizes of the x step and the y step, but the x is the x is negative since I'm moving to the left, and the y is also negative since I'm moving downwards. So this is my final component form for vector u. In the next problem, we want to find the magnitude and bearing of this vector. And again, I think it's really helpful to kind of visualize what's going on here. So let's imagine that I'm on the coordinate plane and I've got an x step of 4 in the positive direction, 1, 2, 3, 4, and a y step of negative 3.5. So this is my vector b right here, and that is comprised of a step of 4 to the right and a step of 3.5 down. So if I want to find the magnitude, really I'm using the Pythagorean theorem. The magnitude of vector b is going to equal the square root of 4 squared plus negative 3.5 squared. And that comes out to be the magnitude, the magnitude of vector b comes out to be 5.3. The angle that I'm interested in is the angle from north to my resultant. That's my bearing. And it's going to help me if I can find that acute angle right in here. So that's going to be, if I call that theta, theta is going to be the inverse tangent of my opposite over adjacent. And let's just use positive values here since I'm just finding the acute angle. So the theta is going to be the inverse tangent of 3.5 over 4, and that comes out to be 41.2. So this little angle right here is 41.2, and the bearing is going to be this little angle plus the 90 degrees that I already rotated. So the bearing is going to be 41.2 plus 90 degrees, and that comes out to be a bearing of, this is now 5.3 in my magnitude, at a bearing of 131.2 degrees.